Continuing lesson 9.2 on quadratic functions, page 554, got it, number 1. They want us to graph this function. So once again, what's different on this equation than what we've been dealing with is that we have that x term, that middle term, that's going to shift our line of symmetry. So the first thing we need to do is find our line of symmetry, or our axis of symmetry, whichever you want to call that. So our line of symmetry is x equals negative b over 2a. So before I start working this out, I'm going to go ahead and recognize what my a and b terms are. Remember our formula, our equation, it's like y equals ax squared plus bx plus c. So a is the coefficient of our squared term, so we can put a 1 there if you want. So negative 1 is going to be our value of a. 4 is going to be our value of b. If they asked us to do it, we don't have to do it on this problem. We'll talk more later in the chapter when we might need to know c. C would be negative 2. Again, we don't really need that for what we're doing on this problem. So at that point, we can just substitute those values in. So if b is 4 and if a is negative 1, then we can simplify that. So that would be negative 4 over negative 2. Negative divided by negative would be a positive. So x equals 2 would be our line of symmetry. So line of symmetry is x equals 2. And so what that means is on our graph, we can make a dotted line there. Dotted line because it's not really part of the graph. It just helps us to figure out what some points on the graph are. So once we have the line of symmetry, so at this point we are going to find our vertex. Our vertex is always on the line of symmetry. So if the line of symmetry is x equals 2, our vertex is going to be 2 something. And the question is just, what is that something? In order to find that, we're just going to substitute 2 back into our equation. So everywhere we see a 2, everywhere we see an x rather, we'll put a 2. So 2 squared is 4. If you want to go ahead, 4 times 2 is 8. So work that out, and we get 2, which means our vertex is 2, 2. So kind of our key information so far, line of symmetry, x equals 2, and vertex is 2, 2. So we know the vertex, that's either going to be the highest point or the lowest point on the graph. So we go to 2, 2, put a dot there. And then what we can do is think about, for this graph, whether that's going to end up being our highest point or our lowest point. So on this equation, if we look at your a term, what's in front of the x squared, that's negative, so this is going to open down. It's opening down, means that vertex is going to be our highest point in this case. So at that point, we can go and find some other points on our graph. And we want to have a total of 5 points, really. So we already put a 0 for x, so I can't do that again. Oh, no, we didn't. We put a 2 for x. So I'm going to use 0. Anytime I can use 0 and 1, I'm going to use those. And then it's up to you if you want to. You know, it's y equals negative x squared plus 4x minus 2. If you want to put that middle column to help you substitute, you can. If you want to just work it out to the side, you can do it that way, whichever way you prefer. So we put a 0 in for x. Really, everything's going to fall out except our c value. We talked about yesterday. That c value is going to be our y-intercept. So 0, -2 would be another point on the graph here. 0, -2. And then what we can do is we can look at how far that point is from our line of symmetry. So if we look at this, that's 2 units to the left of our line of symmetry. If we go 2 units to the right of the line of symmetry, we should have another point on the graph because it's symmetric. We can fold on that line of symmetry and it should match up. So it looks like 4, -2 should be another point on our line. So for that, we don't have to go and work all of that out. We can just say 4, -2, and then if you want to just put mirror image, or if you want to put MI, just abbreviation for mirror image there or something, you can, just to show that you don't really need to do the work for that part. And then we haven't done 1 yet, so I'm going to go ahead and put a 1 in. Now this part we have to be careful. This is where I've seen people make a mistake before, because they see the -1 squared and they think of -1 times -1. Actually, it's -1 squared. And what might help you see that better actually is if you put a -1, if you put a 1 in front there, then you might see that as -1 times 1 squared. Might make it easier for you to make that distinction, okay? Because the difference is if we square 1, 1 times 1 is 1. We still have that negative in front though. 4 times 1 is 4, and then -2. So this will be 3 minus 2, which is 1. So 1, 1 would be another point on our graph. So 1, 1, which is going to be right here. And then again, we can look at 1, 1, we're 1 unit away. Let's go 1 unit away on the other side, and that'll get us to this point, 3, 1. So 3, 1, got kind of a messed up table here, but something like that maybe. 3, 1 would be another mirror image point for us. So at that point with the vertex and those points, now we have a total of 5 points. We should have a good idea of what our parabola is going to look like, so we can go ahead and draw that. So what we're going to do, we're just going to draw this thing. We're going to try to give this a little bit of a V shape, or sorry, a U shape rather than a V shape. Okay. Make sure you go past those last points that you drew and put arrows on the end. And again, it should be symmetric to your line of symmetry if you did this correctly. So that would be our graph for the got it number 1. Top of the next page talks about this formula that we can use to find how high something is above the ground. And again, that has to do with gravity. So T is the time, C is the initial height. Now what we're going to do in this lesson, we're going to go one step further here. And we're not just going to have a falling object. We're going to be having, in this case, we're going to be talking about if we launch a t-shirt. So the launching is going upward and the gravity is going downward, and we're starting with an initial height. So we've got really kind of 3 different components to this. So that's going to be an equation. If you're doing one of these problems like this, that'll be an equation you'll be wanting to look for to give you a starting point. So problem 2, the slingshot launches t-shirts at the crowd. T-shirts launched with an initial upward velocity of 72 feet per second. That's going to be going in place of V in our equation. It's caught 35 feet above the court. So how long will it take the t-shirt to reach its maximum height? What is the maximum height? What is the range? Okay, we got a lot of questions to be answered here. So again, going back to this formula, all we're doing is substituting in 72 is our velocity, and the other thing they didn't tell us in writing, but if you look at the picture, you can see we're starting at 5 feet above the ground. So that's going to be our initial height, which is going to go in place of c. So that's how they got this equation. Okay, again, it's just taking that formula from up above and just substituting in place of the v we put a 72, in place of the c we put a 5. Okay, so if we're working this out, first thing would be finding the line of symmetry. So b is 72, a is 16. A is negative 16. Work that out, you get 2.25, and then put 2.25 in, substitute that in, you get 86. So 2.2586 is going to be our vertex. What it means for us in this case, we can kind of think about the graph. The graph opens down. It's a parabola that opens down. And this time the vertex has a little more meaning to you maybe because it's a real life problem. That is the maximum height of the t-shirt. That's saying after about 2 1/4 seconds, it reached a height of 86 feet. Okay, that's assuming that it's not hitting the ceiling or anything. We don't know anything about the dimensions of the room, so we'll assume that it's allowed to go that high and not hit anything. So the range is our possible y values. So the range is actually, we don't actually have this whole graph quite because we're just going to stay in the first quadrant. We're not having a negative time. Also, it's actually going to be, I don't know what their exact numbers are they're going by here, but they're starting at that height of 5 feet. And then remember what happens, it gets caught at 35 feet. So somewhere over here, it actually is being caught, and we wouldn't have this part of the graph either. So a little different, if we were actually graphing what happened here, we wouldn't have arrows on the ends. It would just be starting from the one red dot going to the other red dot there. So the range, the y values, the lowest height that the t-shirt ever is when it's being shot, 5 feet. The highest it ever gets to is the 86 feet. So it goes from 5 to 86 would be the range. So that means, like they said in the book, you could say basically h is between 5 and 86. Or if we use interval notation, it includes 5 and 86. We could put 5, bracket 5, comma 86 bracket. Again, the brackets means it includes those points. Okay, so that's one method of doing this. We could kind of think through that. The other method would be if we're allowed to use a calculator. If you're allowed to use a calculator, or if you're doing this on homework and you want to just check your answer if you did it by hand, what you can do is you can actually find the maximum. So just using the steps here exactly like they say in your book, you could go to y equals, you could graph this, and you could do calculate maximum, and then we could figure out what this maximum point is. It's going to ask you for a left bound. You're going to make sure you're to the left of that point, hit enter. Right bound, you're going to make sure you're to the right of that maximum point, hit enter. And then it'll reassuringly ask you if you want to guess. And then you'll hit enter again. And then it'll end up giving you that value like it shows on the screen here. Okay, and again, I can go through that with you. I can find probably a video online where somebody's explaining that. I don't know that I can import my calculator program into this app, so we'll do that separately if needed. So on the got it 2, we're going to start again with that general formula that we just talked about. The one thing they don't really clarify here, we're going to go with the assumption that we're starting out from a height of 5 feet, where this is being launched from. In this case, upward velocity is 64 feet per second. 5 is our initial height. So this will be our equation to start with. And then we need to find our line of symmetry, or our axis of symmetry. So this will be A, this will be B, and I forgot my T after that on my equation. Sorry about that. Okay, I really encourage you, I know you know A comes before B, but if you circle those and put the letters next to them, there's going to be less chance of making a mistake when you substitute these in. So when you simplify this, you'll get x equals 2. So x equals 2 is going to be our line of symmetry. If we're not necessarily having to graph it on this problem, you might say, well, what's the point? I don't need the line of symmetry. Well, you kind of do, because your vertex is on the line of symmetry, and you have to find the vertex here. So vertex, we're just going to substitute a 2 in place of t and see what we get here. So if you work all that out, would be 69, which means our vertex is 269. What does that mean? Well, x is going to be our time, okay, because we got t where the x is normally. This is like t and h instead of x and y, really. So what that means, after 2 seconds, it's reaching its highest point of 69 feet. And that's answering the questions kind of what they're asking us there. So how long will it take to reach the maximum height? That would be 2 seconds. How far above the court level would it be? That would be 69 feet. What is the range of the function? So the range, that's our y values. Think about this again. It got caught 35 feet above the court when it was coming down. So it started out 5 feet above the court. It went up, hit its maximum, started coming down, and then it never got below 35. So the lowest point it ever was 5. The highest it ever was 69. And so if you want to do interval notation, that would be your range for this function. So if we look at the lesson check number 1, they're asking us to graph this function. In order to graph this function, again, first thing is we're going to find our line of symmetry. So line of symmetry is x equals negative b over 2a. When you write your line of symmetry, make sure you put x equals something for your line of symmetry. I've had people do these problems sometimes, and they'll say their line of symmetry is 3 or 1 or negative 2. Just a number, that's not a line, so you've got to make sure it's x equals. So we look at this to start out with. A is 1, b is negative 4, so we're just going to substitute in. Be careful on this one, because b is negative 4, so we're doing negative b, so negative of negative 4. Opposite of negative 4 would be 4. 2 times 1 is 2. 4 divided by 2 is 2. So x equals 2 is going to be our line of symmetry, or our axis of symmetry. And again, we can go ahead and draw that in if you want. Normally we'll draw that in as a dotted line. So we can see it's not actually part of the line, it's just helping us find our points on the line. So that's our line of symmetry. And then we know our vertex is on the line of symmetry. Next thing is we're going to find our vertex. So we know our vertex is 2 something. So we can just put a 2 in place of x. So we work that out as -3. So our vertex is 2, -3. Again, our line of symmetry is x equals 2. So vertex here, 2, -3. When you're going to graph these, it's probably a good idea to find your points first. Might be a good strategy before you graph them, so you have an idea when you're making your graph that you have enough room to graph your points. So we've used 2 for x. So some of my favorites are still left. We're going to use 0 for x. If we put a 0 in for x, everything's going to fall out except for that c value at the end here of 1. So 0, 1 would be a point on our graph. 0, 1. That's 2 units away from our line of symmetry. So we go 2 units away on the other side. That takes us to the point 4, 1. Now, if you want to wait to do your mirror image points, I mentioned finding your points before you do the graph, but you know, if you want to find your points, basically it's the y values that we're going to be concerned about anyway. So your y values for your mirror images will be the same. So I know it's probably easier to find your mirror image points by having the graph there to look at. So if you want to just find your ones and then substitute that in. And this one I messed up, sorry, this should be 4, 1. Not 1, 4. We can put a 1 in place of x then, would be another option. If you put a 1 in and work that out. So we've got 1 squared minus 4 times 1 plus 1. So anyway, if we work that out, that should be -2. So 1, -2 would be a point on the graph. So 1, -2. And then the reflection of that would be this point here, which would be 3, -2. That would be our mirror image point. So that gives us 5 points, and then we can connect. And again, always think about, I didn't mention it on this problem, whether your graph's going to open up or down. On this problem, since we had a positive x squared, we knew our graph was going to open up. So that means that our vertex is the minimum. So in other words, when I find my vertex is 3, -2, I know -2 is the lowest y value. So -2 on up is what I need to make sure I have room for on my graph. We'll look at one more of these lesson check problems. Let's look at number 4. On 4, they have f of x instead of the y. Understand that those are interchangeable. You might notice on this one we have a negative a value, so this graph's going to open down. So if I'm graphing, first thing is finding the line of symmetry. A lot of this, it's repetition. If we get practice on going through the steps of what we need to do, then it'll become like second nature. Like some of you, maybe if you're in basketball and you have certain plays that you run, the more you get used to running those plays, there might be several steps that you have to go through, but you know, you'll get to a point where you don't even have to hardly think about what you're doing, and you'll be able to run the correct play. So our line of symmetry here should be x equals 1. And again, we can draw that out maybe. So x equals 1 would be a vertical line here. And then we can find our vertex is our next step. And again, these steps I gave you, so you can kind of just look through those steps and make sure you got those figured out, remember what they are. So if you put a 1 in for x, technically, you know, if we had a calculator, you could type this all in your calculator and it would just give you an answer. Just make sure you are able to do this without a calculator if needed, because we don't always have a calculator that we can use. Okay, so 1, negative 4 should be our vertex. And again, this opens down. So 1, negative 4, that's actually going to be the highest point on my graph this time. It's going to be my maximum point. So 1, negative 4. So really, by looking at this graph, I'm probably going to run out of room with the graph that I have here. And so that's why it's good to decide ahead of time. Find some points ahead of time before you decide what kind of graph to do. So 0 has not been used yet. 0 is just going to give us that c value because all the x stuff's going to fall out. So 0, negative 5 would be another point on our graph. So 0, negative 5 is right here. That's 1 unit to the left, so we go 1 to the right, which would be the point 2, negative 5. So if we already had this graphed, if we're already graphing it, you could put a mirror image point of 2, negative 5. 1's already used up, so you can either do negative 1 or 3. Most people like positive numbers better than negative, so if you want to use 3, put 3 in for x, you can. So this negative is just out in front of this. So 3 squared is 9. 2 times 3 is 6. So negative 3 minus 5 should be negative 8. So 3, negative 8 should be a point on our graph. And again, that's going to be just off the graph here. 3, negative 8. So it's going to be about here. So in other words, I wouldn't have needed all of this extra space up here on this graph. I could have just made hardly anything above the x-axis and gave more room below the below the x-axis that I could graph these points. Would be the ideal thing to do. So that's 2 units away. We go 2 units away on the other side, and that takes us to negative 1, negative 8. So that negative 1, negative 8 would be another point on the graph, and at that point we could graph this. Again, extending past those last points, put arrows on the ends. And that would be our graph. Okay, so again, I know it takes a little bit of time to work through these, but again, you got to get some practice working through this so you can just memorize your steps of what you need to do in order to graph these quadratic functions or parabolas.